Hello, this is Farhan Shakil from the Republic 2.0, and today we've come to you with the third part of this Edexcel May 2025 exam video. In the last video, we've solved up till question number 6, I guess, and now today we'll start from the question number 7, right? So, you know, the last time we've talked about trigonometric questions and the other ones, and now we've got this question number 7. Figure 3 shows a sketch of the part of the curve C1. It has an equation y is equals to f of x, where f of x is a cubic function, and it is passing through the origin and cutting the x-axis at x is equals to 4. So you can see that this cubic function only got two x-intercepts. So the function is going to be y is equals to x square times x negative 4 times by a. That should be the standard form of this cubic function whenever it is going to have two x-intercepts. So now what we're going to do, it is passing through the points 10 and 120. By plugging these points in, I'll get myself a. So in place of y, I'm going to write 120. In place of x, I'm going to write 10 square times 10 minus 4. And I'll be left out with 120 is equals to a times 100 times 6. So now, if I just want to solve it down, I must be having a is equals to 120 divided by 100 times 6, which is going to be something like, 6 times 20 is 120. This 0 cancels out by this 0, 2 times 1 and 2 times 5. So the answer of A has to be 1 by 5. So what is going to be the f of x? The f of x is going to be 1 by 5 x square times x negative 4, right? And now I've got the curve C2. It has an equation y is equals to 1.2 x times 8 minus x. You can easily see that this is a quadratic function. On the following page, there is a copy of the figure 3 called diagram 1. On diagram 1, sketch the curve of C2. So before sketching the curve of C2, I need to write it in a completing square. So first of all, I'm just going to write it like 1.2 times x is going to be something like, if I'm not wrong, it has to be 9.6x minus 1.2 x squared, right? That is how I'm going to write this thing down. And, by writing it down, like by taking negative 1.2 as common, I'll be left out with x squared minus, since I've taken 1.2 out as common, so x squared minus 8x probably. So now I'm going to write it in a completing square form. So y should be equal to negative 1.2 bracket x minus the half of 8 by 2 square, and minus 8 by 2 square as well. We've got the brackets closed now. And now I'm going to simplify it down like negative 1.2 times x minus 4 square. And over here, 8 by 2 is going to be 4. 4 square has to be 16. So I've got this expression. And now I'm just going to write it down like y is equals to negative 1.2 times x minus 4 square, and then plus. Now 1.2 times 16 is going to be something like, I guess 16 times 1.2 would probably be 16 times 1.2. 16 times 1.2 is going to be something like 19.2, right? So we've got these curves. So what does that mean? The y-intercept is going to be 0 minus 4 square, whatever y-intercept you can have for y-intercept. For y-intercept, plug in x equals to 0. So 1 minus 1.2, 0 minus 4 square plus 19.2. And I would be having something like negative 1.2. 1.2 times 16. That has to be something like negative 19.2 plus 19.2, and that comes out to be 0. Now, similarly, if you're looking for the x-intercepts, you just need to plug in x equals to 0, and y equals to 0. So for x-intercepts, you must be having, for x-intercept, I can even use this simple equation. So x must be 0 and 8, right? So I've got x, since 0, 1.2x times 8 minus x. So x should be either 0 or x is equals to 8. That is how the x-intercept work like. So apart from that, we just need to draw that down. So we have got 0 over here. We've got something like, this was 4. So this one should be something like 8. And since the, the maximum of this curve, if you're looking for the maximum of this curve, that has to be 4 and 19.2, right? So 4 and 19.2 must be somewhere up over there. So we just need to plot it down, a quadratic equation like this. So that is how the quadratic equation might look like. Now in the C part, this was the B part. In the C part, we need to use algebra to find the coordinates of the points where C1 and C2 intersect, show each stage of your working. So we've got one of our equation looks like this, and the other equation looks like this. So we just need to simplify them. We can simply equate them up to get the x coordinates. And once we've got the x coordinate, we can eventually get the y coordinates as well, right? So in the C part, for points of intersection, we've got the points of intersection equating, and for the point of intersection, we need to equate above x's. So once, the other one equation that we had was 1.2 x times 8 minus x, 1.2 x times 8 minus x, and we should keep it equal to something like 1 by 5 x squared times x minus 4, 1 by 5 x squared times x minus 4. So now what we can do, first of all, we can simply cancel out this x with this x, right? This x has to be 0. Then we have got 1.2 times 8 minus x is equals to 1 by 5 times x squared minus 4x. Now I'm going to cross multiply these things, right? 5 times 1.2 would eventually be, if you're looking for 5 times 1.2, that should be 6. 6 times 8 minus x is equals to x squared minus 4x. 6 times 8 has to be 48. And 6 times x has to be 6x is equals to x squared negative 4x. Now I'm just going to simplify this equation. And I must be having x squared negative 4x, positive 6x, and negative 48 is equals to 0. And that would be x squared plus 2x negative 48 is equals to 0. So everybody knows that's 6 times 8 times 6 is 48. So I can write it down like x squared plus 8x minus 6x minus 48 is equals to 0. The common thing between x squared and 8x has to be x, and you'll be left out with x plus 8. Negative 6 times x plus 8 as well equals to 0. So the two x coordinates that you'll be having should be x is equals to 6 and x is equals to negative 8. That is how we're going to talk about these x coordinates. And once you've got these x coordinates, you can plug them in any one of these equations. And I'll probably be using, let it be this one, right? So since y was equals to 1 by 5 x squared times x minus 4, I'm going to plug both of these values in this equation. So y is equals to 1 by 5 times 6 squared times 6 minus 4, and y is equals to 1 by 5. Sorry. So you've got 1 by 5 times x, that has to be negative 8 square, times negative 8 times negative 4, right? So you have got y is equals to 36 by 5 times 2, and y is equals to 1 by 5 times 64 times negative 12, right? So the answer of this thingy has to be 2 times 36 is 72 by 5. And the answer of this thingy has to be something like, 12 times 64. That has to be 768. So 768 negative divided by 5. So these are going to be the y coordinates, and the 6 and 8 were the x coordinates. So that is how we're going to try out this question. Now we have got this question number 8. The curve has equation. The point lies on the curve, given that the derivative of that curve is 3 root of x plus kx square, where k is a constant. The equation of the tangent to the curve at P, right? So what does that mean? That this line and this curve has a common point, that is P. It has an equation 10x plus c, where c is a constant. Show that k is equals to 1 by 4. If both of these curve and this line are tangent. What does that mean? Their gradient has to be the same. So if you're going to compare this equation with y is equals to mx plus c, the gradient comes out to be 10. So what does that mean? That the gradient of this curve would also be 10 because the curve and the line are tangent and parallel to each other. So I'm going to plug in f of hash x equals to 10 is equals to 3 root of x plus kx square. We've been given by the point that is p, 4 and 12. I'm going to plug that point in as well. So 10 is equals to 3 times root of 4 plus k times 4 square. So you'll be left out with 10 is equals to 3 times 2, that is 6 plus 16k, right? And now I'm just going to simplify that down. So I must be having 10 minus 6 is equals to 16k, 4 is equals to 16k, and k comes out to be 1 by 4. So that is how I'm going to get myself the value of k. Once you have got k, you have got y is equals to 10x plus c, where c is a constant. We need to also find out the value of c. What we can do, since I just told you that the curve and the tangent are parallel, the curve and this line are tangent at this point. So this must be a common point, right? So I'm just going to plug in this point into this equation and I'll get myself the c. So a second part is y is equals to 10x plus c. We have got the point that is 4 and 12. So 12 is equals to 10 times 4 plus c. That comes out to be 12. 10 times 4 is 40. When you take away from both the sides, 10 minus 40 is equals to c. And c comes out to be negative 28. So that is how you'll get yourself the curve. Now in the p part, we need to find f of double hash x at p, and we need to find out the second derivative. So if you remember, we've already got the derivative, and that was f of hash x is equals to 3 root of x plus kx square. K was 1 by 4x square. We need to differentiate it again because he's asking us for the second derivative. So f of hash x is equals to 3 root of x, what is going to be the differentiation of root of x? It must be 1 by 2 before that, then x by 1 by 2 minus 1. Similarly, what is going to be the differentiation of 1 by 4x square? 1 by 4 as it is, power behind x, and then 2 minus 1. So you will have the final answer, f of double hash x is equals to 3 by 2 x to the power of negative 1 by 2. 2 cancels out by this thing, and you must be having 1 by 2 x. The thing is that we need to find the second derivative at the point P, and point P was 4 and 12. So I'm just going to plug that in as well. So f of double hash x is equals to 3 by 2 times 4 to the power of negative 1 by 2 plus 1 by 2 times 4. And now I'm just going to work this thing down. So I must be having 3 by 2 times, 4 to the power of minus 1 by 2 can also be written as under root 4, something like this, then plus 2. By sorting it down, under root 4 would be 2. 2 times 2 has to be, 4 as well. So 3 by 4 plus 2. Then by just taking their LCM, I must be having 4, 3 plus 8. That must be 11 by 4. So that is the second derivative of x at the point 4 and 12, right? Now we need to find out f of x. So we already got f of hash x. How can we get f of x back? By just integrating it on both the sides, right? So by integrating it on both the sides, I must be having, since for the c part, I've had f of hash x is equals to 3 root of x plus kx square, 3 root of x plus kx square. If we have got this expression, what we're going to do, we just need to integrate it on both the sides. So f of hash x, and over here, 3x to the power of 1 by 2 plus the value of k was 1 by 4 x square times dx. The integration of f of hash x would eventually become f of x, and that's going to be 3 as it is, x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 plus 1 by 4 x to the power of 2 plus 1 divided by 2 plus 1, and then we're going to add c into it, right? So I'll be having an expression f of x is equals to 3x to the power of 3 by 2 divided by half plus 1 has to be 3 by 2 as well, plus 1 by 4 x to the power of 3 divided by 3 plus c. And then we can get f of x is equals to, 3 cancels out by 3, so 2x to the power of 3 by 2 plus, x cubed divided by 12 plus c. So the thing is that now we do not have c, so we need to find out c first. So at the point, the point was 4, and if I'm not wrong, the other coordinate was 12, right? So I'm just going to plug that point in. In place of f of x, I'm going to write 12, 2, 4 to the power of 3 by 2 plus 4 to the power of cube divided by 12 plus c. Now I'm just going to simplify that down, and it must be having 12 is equals to 2 times, 4 is 2 square. That square should cancel out by this 2. Then we'll be left out with 2 cube, and that's going to be 8. Plus 4 cube is 64 divided by 12 plus c. And now I must be having something like 12 is equals to 16 plus 4 3s are and 4 16s are plus 16 by 3 plus c. So the value of c comes out to be 12 minus 16 has to be minus 4 on the other side, and then minus 16 by 3. I'm just going to simplify that down. I must be having 3 as an LCM, negative 12, negative 16, and that comes out to be negative 28 divided by 3. That is the constant of integration. So our final function would just eventually become, everything like that, but just over here in place of c, you're going to write negative 28 divided by 3. That is how we're going to solve this thing down. Now we have got the next question, that is question number 9. In question number 9, you've got a C1 curve and a C2 curve. And having these two curves, we need to describe the single transformation that would transform the graph with equation y is equals to under root x into C1. Well, y1 was under root 2x, right? And now we have got under root x. So what kind of a transformation this is? This is stretch along y-axis by under root 2, right? Initially, we had 12 minus root of x, and now to get rid of this 12, we should be subtracting 12 from this function. So what does that mean? That you need to move this C2 downwards by 12 units. You need to move this curve downwards by 12 units, right? So these are the transformation. You just need to write them down, do not draw them, right? They're just asking you for the description, not the drawing. Now the B part. The graph C1 and C2 meet at a point. Show that the exact coordinate of P is a solution of. Well, C1 and C2 are meeting at a point, so we just need to equate them up. I must be having under root 2x is equals to, and the other thing is 12 under root 12 minus x. I'm going to move this under root x to this side, and I must be having under root 2x plus under root x is equals to under root 12, right? And now I can see I can have under root x as a common, and I'll be left out with under root 2 plus 1 is equals to 12, right? Now we need to divide it on both the sides. So under root x must be equal to 12 divided by under root 2 plus 1. Now, if you remember, we cannot really, talk about the square root in the denominator. So what I'm going to do, I'm just going to multiply under root 2 plus 1. I'm just going to rationalize it. So under root 2 minus 1 divided by under root 2 minus 1. And now I must be having under root x is equals to 12 times under root 2 minus 1 divided by under root 2 square. And then I must be having minus 1 square. Under root 2 square is 2, 2 minus 1 has to be 1. So under root x eventually comes out to be 12 under root 2 minus 1. And that is what he was asking us. Now, in the simplest form, find the exact coordinates of P. So let me get P from here, and then I'll get Y. So to get X, I need to square both the sides. For the C part, I'm just gonna squaring both sides. So by squaring both the sides, I must be having under root x square is equals to 12 times under root 2 minus 1 ka whole square. This square cancels out by the square root. You must be having x. 12 square has to be 144. And under root 2 minus 1 square, if you expand that down, you must be having 2 plus 1 minus 2 under root 2. So the answer of x has to be something like 144 times 3 minus 2 root of 2. That is x. And now you're looking for y. For example, if you're looking for y, you've got 12 minus root of x and you've got under root 2x. So you can just simply plug in their value, right? So y has to be 12 minus, and the root of x, if you remember, was 12 root of 2 minus 1. And now we just need to simplify that down as well. So y is equals to 12 minus 12 root of 2 plus 12. And that comes out to be 24 minus 12 root of 2. So the x coordinate of p would be this number, and the y coordinate of this p should be this number. So that is how we're going to simplify this question down. Now, we've got the last question now. And the last question says that k minus 1 x6 plus 4x cubed plus k minus 4 is equals to 0, where k is a constant. Find the exact solution to the given equation for k is equals to 4.5. If k is 4.5, so k minus 1 should be 3.5 x to the power of 6 plus 4x cubed, and then k minus 4 should be 0.5 is equals to 0. Well, since this is something like a more than a quartic equation, it has a degree 6. So we can suppose that y is equals to x cubed. So this equation would eventually become 3.5 y square plus 4y plus 0.5 is equals to 0. Well, solving this equation by factorization or complete exponent would be a bit hard, so I'm just going to apply the formula. So y is equals to negative 4 plus minus root of b square. That has to be 16 minus 4 times 3.5 times 0.5 divided by 2 times 3.5. Simplifying this down, I must be having y is equals to negative 4 plus minus root of 16. 4 times 0.5 has to be 2, and 2 times 3.5 has to be 7. So 16 minus 7 divided by 2 times 3.5 has to be 7 as well. So now, by just solving this down now, negative 4 plus minus 16 minus 7 has to be 9, and the square root of 9 has to be 3 divided by 7. So the two answers of y that I must be having should be negative 4 plus 3 has to be negative 1 upon 7, and the other answer for y, negative 4, negative 3 should be negative 7 upon 7, and that should be negative 1. Now I'm just gonna, take the plug the values back into it. So I suppose that y was equals to x cubed, right? So x cubed is equals to negative 1 by 7, and x cubed is equals to negative 1. Their answers are in the form of iota. You can just simply keep them the same thing. So you've got the cube roots over here, you've got the cube roots over here, cube roots over here, and cube roots over here, right? You can either solve them like this, or you can apply the formulas as well. So these are the possible answers for x. Now find a set of the possible values of k for which the given equation has no real roots. So we need to solve this equation down for which this equation has no real roots. No real roots means that this equation would not be having any sort of, its discriminant must be less than 0, right? So what I'm going to do, I'm just going to rewrite that equation. And I must be having, for the p part, k minus 1 times x to the power of 6 plus 4x cubed plus 4x cubed plus k minus 4 plus k minus 4. First of all, I'm going to transform this equation into a quadratic one, so I can rewrite it as k minus 1 times y square plus 4y plus k minus 4 is equal to 0. Now, for the for this equation to have no real roots, the discriminant should be less than 0. I'm going to plug the values in. B is 4. 4 square has to be 16 minus 4. A is k minus 1 and B is k minus 4. It should be less than 0. I'm just going to sort it down. So 16 negative 4 times k square, negative 4k, negative k plus 4 should be less than 0. 16 negative 4 times k square, negative 5k plus 4 should be less than 0. And now 16 negative 4k square plus 20k negative 16 less than 0. This 16 and this 16 would get cancelled out, and you can have negative 4 as common. So you'll be left out with negative 4k as common. So you'll be left out with k minus 5 less than 0. So from here onwards, your k must be 0 or your k must be 5. So 0 to 5 are the possible values of k, and that is what we've been looking for. So that is how we're going to do the paper 2025. That is the latest paper that we can have. I hope you have understood all the questions. If you got any questions, please comment. I'll respond. Right. Thank you very much.